In this video, you're going to use your algebra skills to learn how to justify the properties of a shape using the distance formula. Ooh, and I should probably throw on there the midpoint formula. So we're going to start with finding distances. And what distances really means is you're finding the length of the lines below. So why would I say distances? Because really the length of this line is the distance that's between these 2 points. So distances and lengths, they're kind of closely related. I'm asking the same question. So what's the distance between these 2 points? Or what's the length of that line? The way I like to do it to start, now yes, there is a formula and we'll get there, but if you can imagine this as a right triangle, we already know how to do this. So if I make this a right angle, I'd have to draw on this line and this line, and now it's a right triangle. Okay, and the reason I like to do this is because then you can just kind of use something we've learned this year and you've learned in previous years. So what's the length of the side of the triangle? Well, you're going from here to here, so the length of it is 1. It's 1 square long. Whereas this one is 1, 2, 3, 4, 5, 6, 7. So you have a right triangle, and I'm just going to redraw this. Your base is 1, your height is 7, and I'm trying to find this line here, which we call in a right triangle the hypotenuse. And you already know how to find the length of that. How would you do it? Pythagorean theorem, of course. So you do a squared plus b squared equals c squared. Now where c squared has to be your hypotenuse. So I'd plug in 7 for a or 1 for a, doesn't really make a difference here, and I'd solve for c. 7 squared is 49, 1 squared is 1. Go ahead and add those together. You get, I'm just going to come off here, 50 equals c squared. Therefore, if you take the square root of both of those pieces, c is the square root of 50, because you got to get c alone. Okay, so that's one way you can do this, and I can erase all this right triangle. You saw where that came from, and now I know the length of this is the square root of 50 because I made a right triangle out of it. Again, there is a concrete formula to calculate the length of this, or to calculate the distance between 2 points. It's called the distance formula. We'll talk about it later. I like this method because you already know how to do this, and all you have to do is make a right triangle. I want you to pause the video and try this one on your own, and you can check the answer with me in a second. Okay, you set this up on your own. You set up a right triangle, you connected the dots, you drew a right angle, you counted. This is 6, this is 7. Plug those in for A and B. Found your C is a square root of 85. Pause the video and ask me some questions if you have them. So now for more of a geometry connection, although that was because we're using Pythagorean theorem, you can use this to prove that the quadrilateral with these vertices is a square. So let's go ahead and plot those. I have 0, 0 is M, 4, 3 is A, 7, negative 1 is T, and H is, let's see, 3, negative 4. Okay, and I want to prove this is a square, which you might be able to see. It kind of looks like a square. Looks like it has right angles. It looks like all sides are congruent, but you don't know this without proving it. If there's one thing I taught you in this class, you have to prove it. Okay, so there's 2 things you need to know about a square. 1, all angles have to be right angles. You need to prove that. This is what we did yesterday. If all angles are right angles, that means all the lines would meet at what we call a perpendicular angle. So if I looked at MA and I looked at MH, those 2 lines, and you can even extend them if it helps, those 2 lines would have to meet at a right angle and they'd have to be perpendicular. So you can do this on your own as practice from yesterday. Think slope. How do I prove 2 lines are perpendicular? I need to figure out their slopes. Okay, the thing for today is the second part you need to know about a square, which is that, and I'll leave some space for the first part, all sides are the same length. Okay, not just that all sides, or opposite sides are the same length, but all sides are the same length. I need to prove that these are all the same measure. So if this is 10, this is 10, this is 10, this is 10. The only way to do it is to calculate the lengths. And in order to calculate the lengths, it's like what we just did. You need to calculate the distance. So I need to figure out the distance of this between these 2 points, M and A, because that would be the length. Or the distance between A and T, because the distance between those is the length. Okay, an easier way, other than doing Pythagorean theorem, because that can get kind of ugly with that picture, is to use the distance formula. Okay, so the distance formula, I'll call the distance d, is equal to the square root of your x coordinate subtracted and squared plus y minus your y coordinate, your other y coordinate, squared. And I'll apply this in a second, but let's figure out why this makes sense. Remember you had Pythagorean theorem, well, I'm going to do it backwards for a second. C squared equals a squared plus b squared, where c was the distance, right? The hypotenuse was the distance. So to get c alone, you have to square root both sides. If I square root that and I square root that, there's no more c, and it looks like this, which looks very, very similar to the distance formula here. The only difference is that your a is our x coordinate subtracted, and our b is our y coordinate subtracted. Now the reason we have these coordinates is because, remember, we didn't know what a was, we didn't know what b was. We had to figure out those lengths, and this is how you would do it. You'd subtract your x coordinates to find the distance on the x, and your y coordinates to find your distance on the y, which in this picture we just counted, right? I counted this with 6, but really your x coordinate here was 1, your y coordinate, or your x coordinate here was 1, 2, 3, 4, 5. -5. So to find the distance between those, you can do 1, your x coordinate, minus your other x coordinate, which minus a negative is plus, so you'd get the distance of 6. So again, this distance formula is really Pythagorean theorem, just done on a coordinate plane, and like solve for c, just so you know where that comes from. Anywho, in order to do this, you're going to prove all sides are congruent. I want to calculate the length of MA, so the measure of MA, using my distance formula, and the measure of AT. I'll do one, and you're going to do the other on your own. So my distance formula, you know it's a square root. I should probably figure out what these coordinates are. So MA is 0, 0 at M, and A is 4, 3. Okay, applying the distance formula, you take your two x coordinates and subtract them. So x is the first one here. So I'll do the square root of 4 minus 0 squared. Okay, then you have to add, because it's like Pythagorean theorem, a squared plus b squared. And you're going to look at your y coordinates and subtract them. Okay, so I'm just going to do 3 minus 0. You could do it the other way. You'd get the same thing because you're squaring it. And then all you have to do is simplify this up and solve. So 4 minus 0 is 4. So you're going to do 4 squared. 3 minus 0 is 3 plus 3 squared, which is just 16 plus 9, which is 25. And the square root of 25 is 5. So this length is 5. In order for this to be a square, all sides have to be 5. So I'm going to have you go ahead and calculate the measure of AT on your own using the distance formula and see if it's also 5. We could do all 4 sides, but it's just tedious, so if you just do AT, we'll move on. Again, pause the video and do that on your own. Okay, you should have paused that and calculated the length of AT. You needed to know that T was 7, -1 that was told to you. So I plug it into my formula. I do x minus x. So one of my x's is 7. One of them is 4, 7 minus 4, squared. Then I add y minus y, -1 minus my other y coordinate is 3, and square it. Okay, simplify that, 7 minus 4 is 3, -1 minus 3, it's going to make it more negative. So this will be -4, and square it. 3 squared is 9, -4 squared is 16, you get the square root of 25, and you also get 5. So these sides are congruent. You would need to do the other two, but we can just say, it's pretty safe to say that this is a square. And so you can use the distance formula to calculate lengths to confirm shape properties. And you can also use the midpoint formula to do the same kind of thing. And we're going to start with a basic example on a number line. Find the midpoint of AB. So here's AB. Where's the middle of it? So let's see, there's 1, 2. The middle would be right in between here, right? Because they both go 1 and then they kind of go a half. You'd find the middle, blah, blah, blah. There's an easy counting way, and then there's a concrete formula. So just by counting, halfway would be here, and that's 1.5 in, 1.5 in both ways, because a midpoint has to be equidistant. So in between -2 and -3 is where my midpoint would be, so it'd have to be -2.5. Okay, now a formula for this is you're kind of taking an average. So I'm going to take -4, and I'm going to take -1 and add them, but then I want to find the middle. Middle means halfway, so I have to divide by 2. -4 plus -1 is negative 5 divided by 2. It's negative 5 divided by 2 will also give you negative 2.5. I want you to try CF on your own. Go ahead and pause the video. Okay, you should have got 3.5. I'll give you a couple ways to think about this. 1, you can count. So this one has to go 1, 2, 3.5. This one also goes 1, 2, 3.5. So that's in the middle, and that's 3.5. 2, you can take the two endpoints here of C and F. You have 0 plus 7, add them together and divide by 2, and you get 3.5, which is kind of what I did there. Okay. The reason you have to add is because we're finding the distance between the 2 points. So to find the distance, I would take 1, 2, 3, 4, 5, 6, 7. Okay, so you add them together to get that distance. And you have to divide by 2 because it's halfway. And that gives us the midpoint formula, which is you take your two coordinates, add them together, and divide by 2. But if we're talking about a coordinate plane, you have a midpoint would be x comma y. So you have to have the middle of your x and the middle of your y. So the midpoint formula in general, and this may look familiar, is you add your x's, so I'll just call those x1 and x2, and divide by 2. That finds the middle of the x's. But you got to do the same thing with your y. Add up your y's and divide it by 2 to find the middle. Geometry application is you have a triangle with these vertices, and you have a line, and you want to prove that line is a median. So let's just graph these real quick. 2, 10 is A. Okay, I graphed one. You go ahead and graph your own. I'll pause the video. Okay, I plotted those. You have triangle BAE should look like this. If yours doesn't, go back and look how you plotted points. You have point D that lies on BA, so that just means it's on the line. It's negative 2, 8. It's right here. It wants you to prove that ED, so I connected E to D, is a line. It wants you to say that's a median of the triangle. So this reviews some vocab we learned in Unit 1. A median is a line in a triangle, as you can see, that will connect a vertex to a midpoint of the opposite side. Opposite. I'm going to abbreviate it because I don't have room. You can write it smaller if you want. Okay, so it's got to go from vertex to midpoint. So we already know it starts at vertex. In order to prove it's a median, we have to prove that it goes to the midpoint of the opposite side. So really the question is, and I'll write this in a different color, that's not a different color, what am I saying? The question is D the midpoint of its side? It looks like it is. It looks like it's in the middle of AB. Can we prove it though? So in order to calculate the midpoint of AB, we'll have to find the middle of the x's and the middle of the y's. Starting with our x's are 2 and negative 6. So to find the midpoint, you add your x's and divide by 2. 2 and negative 6 gives me negative 4 divided by 2. Negative 4 divided by 2 is negative 2, which is our x-coordinate of our middle. So far, so good. Now we got to do that for the y's. So our two y's are 10 and 6. And we got to divide by 2 to find the middle. So that's 16 divided by 2. 16 divided by 2 is 8. So our x middle is negative 2. Our y middle is a positive 8. And now we've confirmed that D is in the middle of AB. So if we know that D is in the middle of AB, we know that this line is a median, because a median goes from a vertex to a midpoint. If you have any questions about this, please pause the video and ask. Otherwise, you have some problems that you can try on the homework. You need to know the distance formula. You need to know the midpoint formula, so you can study those as well. Have a great rest of your day.